All right, welcome everybody to week 12, day 1. We're going to be improving our Unix skills today and learning how to automate better. So we're going to go over a little bit of Excel today. Your hash table assignment is due on Wednesday. I'm not going to be pushing that back at all, so make sure you have everything done by Wednesday. 10 points are for correctness. You get your code done, pass the test cases, that's 10 points. It's easy. You should not have any trouble getting the correctness done. I've given you source code for 2 of the 3 solutions. Just make one of those the default that works. Pass all your test cases, call it a day. Then move on to doing the report, which will be either very time consuming or slightly time consuming depending on how good your Unix skills are. So let's talk about Unix skills. So the first thing to understand about Unix is that your typical Unix program reads from the standard input and writes to the standard output. And this seems like a very weird thing because in real life we usually don't read lots of data from the keyboard, right? Like we might, we're like testing things, we'll like type a couple things and try it out. But you're not going to type a million things in the keyboard, right? And so like the Unix sort program, you type in apple and Canada, banana, and Montana, and zebra, and artichoke, or whatever. It reads from the standard input, and then after you hit Control D is the end of file character. Then, and a lot of people don't know that, by the way, like if you want it to finish, you hit Control D. Then after it's done reading from the standard input, then it sorts them all and prints them out in alphabetical order. Okay? It doesn't seem very useful, right? Because I can't imagine a time where I would just have 5 words that I need to sort and I'm just going to type them in and have it sorted. It seems very weird. But there's a method to the madness. Okay? There's a reason why Unix utilities are all built this way. And it's actually a very beautiful and very elegant and very powerful design. Okay? And another thing you should probably all learn today is the Control L character. The Control L character refreshes the screen. So if you ever have something appear on the screen that doesn't belong there, Control L, it'll refresh the screen for you. Okay, good. Word to the wise, in case anybody ever dumps the B-movie script to the screen or something like that. So, just hypothetical situation. So, Control L. Okay. So let's show you why this is so interesting. So like the cat program, you type things and it just echoes them back to the screen. Seems very useless. But cat Control L refreshes. If you have an empty command prompt, it clears the screen. But if you're like inside of Vim or whatever, Control L refreshes it. Refreshes the screen. So let's say we've got a file, file.txt. Cat prints the contents of the file to the screen. Okay. And if you have multiple files, it will concatenate them together, hence the name. Okay, so it prints file.txt here, and then it prints foo.cc here. That's what cat does. Now, if I do that, it goes to the screen. But check this out. Vertical slash. This is the first learning point for today. Vertical slash. What vertical slash does is it takes the standard output of one program and makes the standard output not go to the screen, but go to another program. It becomes the standard input of another program. So if, for example, we pipe this into cowsay, then cowsay is now saying the words. Okay? Let me get rid of the screen text here. And so we send the output of one program into the input of another. And then we can Control L, pipe the results of that into lolcat. And then the output of cowsay goes into lolcat. So the standard out of cowsay becomes the standard input of lolcat. And you can composite multiple commands together. And you can actually do very powerful things. For example, if you type who, it'll show you all the people on the server and all of their IP addresses. Okay? And let's say I don't want the terminal, by the way, the terminal, if you echo things into the terminal, it'll appear on their screen. So for example, if you take the bmovie script and echo it into one of their terminals, the bmovie script will appear on their screen. If you want to disable that behavior, you type message, and by default it allows anybody to write into your terminal. You can type message n, and then it will disable it. You can either do that every time, or you can put it into your .cshrc file. You edit your .cshrc file, you can put message n inside of there and disable the ability of people to echo things into your terminal. Now, there is an alias, of course, for editing your .cshrc file. And, oops, come here and just do a message n, something like that. Okay. And then that will disable people being able to mess with you. Okay. Now, so let's do this. So if I get a list of everybody on the server, I can just get their usernames, and I can get the username by selecting a column. Okay, so there's different columns of text: one for the username, one for their terminal, one for the time they logged in, one for their IP address. And I can select just their username by piping it through a Unix utility called cut. Cut allows you to select just one column of text. And so if I cut just their usernames out, boom, there's a list of everybody on the server right now. Now, it's not ordered, so I can send the results of that through sort, and now it's all alphabetized. And if anybody was in, could somebody log in a second time, just so I can demonstrate the point? What? Lol, Portnoff? What are you lolling about? Somebody log in a second time. I want to demonstrate a point here. Somebody logged off. Portnov. There you go. So Portnov's on twice here. All right, so we got duplicates, right? We don't want two Portnovs. That's too many. So we can pipe the results of that through unique, and then you can see that there's now only one Portnov where there was two before. All right. So you could just composite these things together. And I could write this program myself, right? If I really wanted to, I could write this in C++. I could say man wtemp. Wtemp is where you can find the login records, and I could go through this documentation and look at, the username. Oh Lord, I could write that and read from the wtemp file and like put it into a vector and like sort it and unique it, and I could do that, or I could just do this, right? And with Unix utilities, there's Unix utilities for a lot of things, a lot more than people realize. If you want to, for example, randomly shuffle things, there is a program called shuff, and the Unix has a dictionary. All right, so you can go user share dict words like that. So there's all the words in the English language. I have about 100,000 words in the language, and I can pipe the results of this through shuff, and then it's going to randomly shuffle all the words in the English language. And then if I wanted to pipe that through head, head's going to pick out the top 10. And so I have just now randomly selected 10 words from the English language. And I could change how many words I want. I could just get one word if I wanted. And I'm getting mingle, turns, plasticine, onos, armchair. So if you just want a random English word, like, I don't know, you're doing hangman or something, you just do that and just grab a random word out of the dictionary. It's as simple as that. You could write all of this in C++, but why? Right? Why? Every word in English, there's different dictionaries that have different sizes. I've installed, I think, a medium size or maybe a medium large dictionary. But yeah, do you want to know how many words are in the thing? There's a program called word count. So word count tells you how many paragraphs, lines, how many lines, how many words, and how many characters are in the file. And so if you just want to do a line count, you can do word count -l, and that tells you how many lines are in a file. So word count -l, file text. There's two lines in file.txt. Okay. And so the Unix utilities are incredibly powerful, incredibly useful. There are all sorts of resources online that you can use to learn the different utilities. I personally learned from the Mark Sobel book. I bought it used in the 90s. And it's hopelessly out of date in terms of like using the motif window manager and things like that. But there's a massive reference section. And it's got like, here, tail, which shows you the bottom lines in a file. So if you want to see the very last lines in the word dictionary. You can pipe it through tail, and it'll show the bottom 10 words in the English language, which are apparently E with an accent over it. Okay. And you can customize how many lines are displayed that way. How to make a directory. Display one page of text at a time with more. Head, finger, expr, cron tab. Cron tab will run things periodically. There is an incredible amount of Unix utilities, and the way that I learned it was every day I just go like this. Whoop, I just open it up, and I'd like, all right, I'm going to learn about the Unix mail command, how to send email. And I've actually used that in my professional career any number of times. Because, check this out, I can pipe things into mail and email people. So I can take the entire English dictionary here and mail Hazelton. -S, what's up? And so Hazelton just got an email with the entire English dictionary in it. So, so we come Hazelton and go to Alpine. He has not checked his email yet on the server. But yeah, so like in my professional career, there we go. Hey, 1 megabyte of file, and there is an email with the entire English directory in it. Please don't abuse this, by the way. So if we quit, and so yeah, but in my professional career, I've used this where like I will do a complicated computation or something, and I just say, all right, well, let me mail it over to you know somebody at some email address, right? So I have I have all my computations at the very end, pipe, mail, boom, they get an email with all the results. Easy. Yeah. And so the Sobel book, I would recommend, or you can just check various websites online, things like that. Every time you log in on the server, it will tell you about a website at Surrey. This one here. And it's really worth going through. What we're covering today is in chapter 3 of it. And I tell everybody in CSI 40, like, do the tutorial, and nobody does it. A few people do, I guess. But this is all tutorial 3. And tutorial 3 is 2 pages, right? That's what I'm going to be teaching today. So you would have known this all along. And there's all sorts of useful stuff in it. So in addition to pipe, which you can use to connect things from one pipe, cut field 1, delimited a space, there's all the people, and I can pipe the results of that through sort, and I can pipe the results of that through unique, and there's all the people on the server right now. In addition to that, I can actually do this as well. So the right arrow takes the standard output of the last program and writes it to a file. So instead of this getting displayed on the screen, this is going to go into a file that I'm going to call A. All right. Then A, there's the stuff. Okay. And you can do it the other way around as well. If you want to read from a file, you do that. Okay. Now, if you want to shuffle, and shuff normally takes standard input, right? You can have shuff read from the file instead, and it'll shuffle all the usernames on the server. And so you can do that, and then type the results through head -1 and randomly pick a person on the server right now. So you can randomly call on people in class. Very simple, very easy. Okay. Easy, breezy, beautiful cover rule. Okay. So when you know the Unix utilities, the reason why they read from standard input and write to standard output all makes sense, because that's how you get the pipes to work. The pipes always connect standard output of one to the standard input of another. And if you want to start off with a file, you can use the left arrow like that to start the thing going, and then you can pipe, and at the very end of the day, you can write that into a different file, and so you can composite these different Unix utilities together and do all sorts of very powerful, very interesting things in a reasonably small amount of time. Now, the shuff utility in the CSI 41 12 o'clock section, I wrote it from scratch in 45 seconds, I think. Was it, Aaron? 44 seconds, something like that. It took me to write shuff from scratch. So it's not like, I can't write these things, but it kind of hurt my wrists a little bit typing that fast. So 45 seconds, yeah, okay. Yeah. So it was 45 seconds for me to do shuff from scratch. I don't know. You guys want to see me do it again, or do you? So shuff reads from standard input, shuffles them, prints it to the screen. You want to see it? All right. Time trial. All right. Let's see. I've got this thing's up a little high. Let me lower my desk a little bit. I need to get into racing position. Gotta get my wrists warmed up. All right. So, all right, Hazelton, get a timer ready. I trust you to have an accurate time. All right, let's do this. You got it? All right. On your marks. Let's make sure I've got my cursor selected. On your marks. Get set. Go. Okay. No! What's happening? It's lagging. Server's lagging. Somebody's running they're doing their runs on the server. Okay. I have stream ends file.txt. Actually, no, we'll just do cn, right? So string s equals read. We'll read one word at a time. Vector of strings named vec. Okay. Vec dot push back s random shuffle vec dot begin vec dot end. Okay, for every string, typing fast enough. Vex s. Okay, done. What's that?
52.
Yeah. There's a bug in it too. There we go. Yeah. I don't know if I want to count that lag against me because the server just like froze for a second there. Okay. There. So randomly shuffles it. You got 53 seconds too. I know. Slowing down. All right. Oh. So yeah. So what we could do is take cat. User share dict words, cat user share dict words, and pipe the results into a.out, and you can see it's shuffling the standard library, or the standard dictionary. So, not too bad. 51 seconds, yeah. All right, I want to do this again. Let's do this again. Your marks, let me know when you're ready, Aaron. I can do this better.
Let me know when you're gonna start.
All right, go. All right, call it.
38.
No, it didn't compile.
Oh no.
Ugh.
Vector of int.
How many seconds?
38, but including that, that'd be like.
Yeah, fair enough.
Yeah.
I need best of three. All right. Ready?
Hold on. Okay. Let me know when.
Vector string named vec. Call it.
29.
How many?
29.
29. I'll accept 29. All right.
Yeah.
All right. 29.66. All right. See if that holds up. See if that time holds up under. New personal best. Let's go. I know. I screwed up on spelling string. I normally type on my screen in front of me, and I'm at a weird angle where I'm like looking at my third monitor and typing like this. So it's do it blindfolded. I don't know. Copy paste maybe. Okay. So yeah, the point is you can write these things yourself, but why do it? All right. So let me show you a fun trick that I did when I was in college. I was a tutor. I was like a Min Corelli, and one of the things I did was to sit in the corner. I would have a lab to myself for about 3 hours, and I'd sit in the corner facing the wall, and students would come in and sit down and log in, and I'd be like, "Oh, hey, Min Corelli, how you doing?" And they'd be like, "Wait, how did you know it was me? You didn't ever turn around and look at me." I'm like, "Oh, I could just tell by the way you type," you know. And what was happening was I had a script that was running this over and over again, and every time somebody logged in, it would display, right? Beep. It would beep at me and say like so and so just logged in. So I think I still have it from last class. So here you go. Yeah. So basically, infinite loop. It does a while. It does a sort unique, puts it into a file. It diffs the old file and the new file, and if there's ever a change, it prints it to the screen, and then it moves the old file to the new file and does just this in an infinite loop. If I want it to be a little more server friendly, I could like add a sleep or something out here. So go to sleep for a second. There you go. I actually had a whole bunch of things. It would beep and it would display a thing, and it would finger them to get their full name and stuff like that. But let me just show you what this looks like. So somebody log in, somebody log off, and you'll see what happens here. So you can see as people are logging in and logging off, it shows the log-ons and log-offs and things like that. So I also had it filtered so it only look at the IP addresses for the lab. So people that were on the server remotely wouldn't count, but like when people would sit down in the lab, and it would actually, I think I had it set up so each of the machines in the lab had their own IP address. It would actually tell me, you know, row 2, computer 7, you know, Portnoy just sat down, you know. I'd be like, hey, Portnoy, how you doing? And they all thought I was a wizard that could determine people by their footsteps and their keyboard. So finger gets information on them. If you have a .plan file, you can actually put information there that gets displayed if people finger you and things like that. But it's not configured currently with your name or anything like that. So it doesn't really reveal any information that you won't get anyway. Okay, so that's kind of the basics of like Unix piping and redirecting and things like that. Very useful stuff. You kind of got to know it if you want to be an automation specialist. And that's kind of what this homework assignment is designed to provoke you into doing. This assignment is possible to do by hand. You could run a.out 120 times. It's possible. But it's supposed to be annoying. And it's supposed to be annoying enough that you start sitting there and like asking yourself, is there a better way to do this? Okay? And so for the homework assignment, you're going to have to make 120 different input files. Okay? And I've told you different things in lecture than is in the README file because I've mixed up this. I've redone this homework assignment like 5 times, and so if you're asking what you should do, either what I said in lecture or what's in the README file, the answer is either is fine. I'll accept either. It's not a big deal. 10 points for correctness. You should be able to get that all because I've given you plenty of source code for it. But then 10 points is for the report. And to do the report, you're going to have to run your program 120 times. I recommend running it 600 times, though, because you want to run each run 5 times and then average the results so that you smooth out any discrepancies in the timings. If you don't do that, your timing data is going to be really rough because there's quite a few variances in times. Like they fluctuate quite dramatically. Okay, so I've given you a program called Generator that will generate a mix of commands for you. If you look at the source code in generator.cc, It will do some inserts, like if you pass in 10, it'll do 10 inserts, it'll do 5 removes, and it'll do 10 searches. So it creates a mix, a combo, as you will. And you might want to add change in there or something like that as well to it. And it will generate a input file of size based on whatever you pass in as the command line parameter. Okay. So if you run generator, you pass in 10, it makes randomly makes 10 inserts, 5 removes, and 10 searches. Okay. And so you could run this by hand. You could say generator 10, and we're going to call this mixtape 10, and we could run it with 20, 20,000 or something like that, or 200,000. Mixtape 200,000. Yeah. You can make all 120 input files by hand this way if you want. But why? Why would you want to do something by hand when you can automate it, right? So it would be nice, right, if you could just make a shell script that would automate your thing. And so here's how you do that. So you make I did this in the previous class. I could retype it, but I'm not going to. It's pretty simple. And this is technically not even necessary if you're running inside of DCSH or whatever. So what this is doing, it's saying for each x, and then this is going to create, so sequence 1 to 10 generates the numbers from 1 to 10. If you say sequence 1 to 10, this is a Unix utility, it will generate numbers from 1 to 10 counting by 2s. Okay. And so what I did was I said starting at 100,000, counting by 100,000s, going up to 1 million. So this is going to generate 10 numbers, 100,000, 200,000, 300,000, etc. Okay. And this is within backticks. Backticks mean run the program, and whatever the results of the program are, put it here. And so if you could imagine this being this 10, 20, 30, 40, 50, then that's going to run generator 5 times. The first time through the loop, x is going to be 10. Next time through the loop, x is going to be 20. Next time through the loop, x is going to be 30, etc. And it sets x, the variable x, to be each one of these in turn. It's a for each loop. It's like the range-based for loop we have in C++. And you access variables in Unix via the $, like that. And what's nice is that you can actually attach them to a word like that. And so this is going to run generator passing in 10, and it's going to write it to a file named inputbob10. And so if we run this shell script, remember, in order to make a shell script runnable, everybody may, or just user, or everybody, who cares, everybody may execute generator.sh, or generator, what do I call it, generator script.sh. Once you do that, generator script.sh, and you will see that we now have inputbob10, inputbob20, inputbob30, so on and so forth. Okay, so that's a fast way of generating large numbers of input files. Okay, so any questions about that? So it's a very simple shell script. It's just automation. That's what I'm telling you. The more Unix you know, the more you can automate your life, and the less grunt work you do. Grunt work is the worst part of working, right? Like, computer science as a field is actually pretty fun because you're solving interesting new challenges, but nobody wants to sit there and make 120 like input files by hand. Like, that's just a waste of everyone's time. Computers are really good at doing dumb, boring, repetitive stuff, and so write a shell script for it. You know, like, learn how. Bash is not the same. Bash is not the same at all. But I'm a moron. I use TC shell. So, I use TC shell because the shell scripting looks like C. And so I don't have to mentally shift gears when I switch between them. I've done bash scripting before. I could again. If I need something in bash, I write it in bash. But, yeah, it's just, you know, don't copy me on this. Learn bash. Bash is 9,000 times better than TC Shell. Okay. So I posted that shell script on there, and that use that to make a set of 10 input files, and then make one set for inserting and searching, make one set for inserting and deleting, one for inserting and changing and searching. However you want. You're going to make 120 files, and then you're going to run them. Okay. So what makes it better than TC Shell? Okay, so for example, when you for example, when you run the timing script, it's going to start running. I've already copied over all those input bobs. It's going to run input bob 100,000, input bob 1,000,000 because it's alphabetized. And all the output goes to the standard output, right? And so in TC Shell, I can do this. I can write this to a file, but you'll see that some of the numbers still appear on the screen. And the reason why I do it that way is because I want the ability to, all the details with running it on this, all that's going to be, but all the timings is actually appearing on the screen. So I could just copy and paste the timings in a giant block without needing to cut out all the extraneous stuff. Now, in Bash, you can actually send this, because this is standard error. In TC Shell, you can send both the standard output and the standard error to a file like this, but you cannot split them into two different files. In Bash, you can. In Bash, you can send the standard output to one file and the standard error to another file. TC Shell can't do that. It's either standard out or standard out and standard error together. And there's hacks and tricks around that. For example, you could run this in a subshell like this and do this like that. And now I've essentially done the same thing that Bash can do. So when you do parentheses like that, it runs it in a separate shell. And so the inner shell is writing all the standard output to B, and then the results of that come out, and the results of that get written into a file called A. So A is going to have all the standard error, B is going to have all the standard out. So there's, I've learned to work around my handicap. Let's put it that way. Why isn't cowsay in CSHRC? I don't know, you can put it in there if you want. So this is going to run for a while. And check this out. If you have a long-running program like this, you could open up another, what you could do is you just go to Starbucks and get some coffee for a couple hours and come back, all your runs are done, right? But, you could do this too. Watch. Control-Z, backgrounds it, but it suspends it, okay? So if I type htop, you'll see it's not running. Both cores on the server are idle. Now, if I type background, what this will do is it will run that shell script that I just backgrounded in the background. And so that ampersand there means it is running in the background. So now if I go to htop, you can see that htop has one of the cores pegged at 100%. And the reason why it's doing that is because it is running wkernel right here, 8.0. It is running my big thing in the background. And this is why you should not wait until tomorrow night to start doing your timings, because the server will cry. There's only 2 cores on the server. I pay $20 a month for the server. It is not a powerful server, okay? Mincorelli did a workshop last Friday on how to install WSL, Windows Subsystem for Linux. You can take your code off the server, put it on your local machine, compile it, and run it. All the shell script stuff will still work, I promise. Unless they don't have TC Shell installed, in which case you can install it. And you can do all the timings on your local machine. That way the poor 2-core server will not hamper you. Okay. There will be no extensions or mercy granted on this assignment. If the server is too slow for you, download it to your local machine right there. Get the timings on your local machine. Okay. So you shouldn't wait till tomorrow to do the assignment. Yeah. Tomorrow night, the server is going to be, there's only 2 cores. So that means there's 2 students who can be running at full speed at once. If you have 20 people running at full speed, that means you have each person running at 1/10 the normal speed. It will timeshare you out to 1/10 of a CPU. And it will take a long, long time to run. Okay. So all this is still running. If you want to see you're currently running jobs, you can type jobs, and it'll show you everything that's running in the background. If I were to close PuTTY right now, though, it would quit the job. And the reason for that is because when you close a terminal, or if the internet goes down, or you get disconnected and log off, whatever, it sends what's called a hang-up signal to every process you have open. And that tells the process that you've disconnected from the server. And what Vim does, have you guys ever seen a swap file in Vim, like a .swp file? You launch Vim and it's like, hey, a swap file was detected, that kind of stuff. Yeah, so it does that for two reasons. Either you have Vim already open, right? Like if you edit main.cc and background it with Control Z, which backgrounds it, it suspends it, and you try editing it again, it'll tell you it's already open. And the key thing to know about that is it'll say the thing's still running. So don't ever open it up again when it's still running. What you need to do is quit and type foreground. FG is the command to foreground a backgrounded task. And now we're back in Vim. Okay. So Control Z suspends a program and puts it in the background. You can run it in the background by typing BG, or you can bring it back. It's like minimizing and unminimizing. So if you type FG, it unminimizes it and brings it back to the front. Now I've got, timing script still running, so let's background it again and continue running in the background. Okay. So the other reason why you get a swap file is if you have Vim open and your Wi-Fi goes down or something, it sends a hang-up signal to Vim. Vim says, oh, they disconnected, let's save a copy of their thing so we don't lose any work. And when you do that, let's see, I can probably trigger that. So if your internet crashes, your jobs on the server will quit, yes, unless you run them with a command called nohup. So nohup is a command that will, it finished. You can nohup a.out or whatever, and then what that means is even if you close PuTTY, it'll still run. So nohup timing script run in the background. If you do that, it'll run timing script in the background, and even if you close PuTTY, it'll keep running in the background. So, okay. So let's take a look at A. So here's all of our timing data. Let's take a look at B. Here's all of the text. Standard output went to that file. Standard error went to that file. Okay. And what you're going to want to do is take all of this data and graph it. Okay. So you're going to want to use shell scripts to automate your runs. You want to use shell scripts to automate the generation of your input files. You want to use shell scripts to automate everything in your life that can be automated, because tediously and pointlessly repeating tasks over and over again is boring. I'm sorry. I mean, I know some people like that. They want to do the same thing at their job every day and never have any surprises and things like that. Not for me. I like having, new stuff, right? I don't like running a program 120 times. I will write a shell script to run it for me. Not why you change your major to C-side. I mean, changing your major to C-side, yeah, you don't change your major to C-side to do repetitive stuff, right? I also recommend putting the timings in a CSV file. Then you just import the CSV file into Excel, sure. Okay. Or you can rewrite your program so that it outputs things directly in CSV format. He'll recommend some resources to learn shell scripting. Yeah, the tutorial that appears every time you log in is where you learn Unix. Is the best tutorial in learning Unix. And shell scripting is like, remember, you just make a file, right, and just be like echo public bmovie script, right? You can just put commands like do echo hi. You just put commands into a text file, and then if you make it executable, chmod everybody may execute foo, then you can. That's just a text file, right? There's nothing special about it. That's just what I just typed. It's just a text file. Normally when you do shell scripting, you want to put at the very top a shebang, which is that thing there that tells you which shell you should run it as. It's kind of traditional. You don't have to. It'll run in your shell if you don't specify one. And then you just run it, right? And so, oops. not echo, it's cat. And so if we run that shell script we made, it prints the entire bmovie script, and then it prints everybody on the server, then it prints hi. You can just put all your commands into a text file, right? And just make it executable, and it'll just do it. Like, that's all there is to learn shell scripting. Now, as far as things like, how do I do a loop? How do I do an if statement? How do I, right? You just Google it. Right? While true. Make a beep character. Oh, I've turned off beeps. Oh. That would just sit there and beep, 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 beep. Yeah, just Google it. How do I do an if statement? How do I do a loop? For each x... Let's see if this will work. Yeah. So for each word in this, it's going to do all these, and yeah. So you can literally, for every file name file, the thing, it's going to print the name of every file in the local directory that begins with the word file. Here's every file in the local directory. ls-l, pipe into woolcat. There's I don't know, my entire file system, I guess, pipe through a woolcat. It's whatever. What are the points on who mean? That's your terminal. So a terminal is literally just a file on the system, and if you write to that file, it appears on their screen. And that's how some mysterious individual was able to send the entire bmovie script to everybody on the server. There's also a command called wall, and wall will broadcast onto the server. Remember to hit Control L to refresh your screen. Helpful reminder, right? And so that's going to appear on everyone's screens right now. Rather than deleting it, which will delete your code, just hit Control L. Okay. So, yep, and there's plenty of tutorials and things like that. Honestly, though, to answer your question less flippantly, the way that I learned Unix shell scripting was in part by reading that book and just learning a new Unix utility every day. The actual shell scripting is quite easy. Min Corelli was asking me last night, like, how do you learn a new programming language? And it seems insurmountable, because like learning C++ takes forever, right? Because there's so many like weird corners and sharp edges and things like that it just seems like a never-ending task at learning C++, which is true. C++ it's impossible to know everything in C++. Bjarne Stroustrup is constantly surprised by things in C++ he didn't know about. He made the language, right? But in general, to learn a new language, all you have to do is learn how do you make a variable, how do you make an if statement, how do you make a for loop, how do you make a function, how do you make a class. Like, once you understand the basics, I took a programming language class, and we learned a new programming language every week. And it seems impossible. Like, how do you learn a new language in a week? Well, because they all have the same basic tools. They're just the syntax is different, And once you kind of understand the syntax, it's easy. The hard thing is the different mindset, right? It's like when you're learning Rust. Rust has a different mindset than C. Like in Rust, everything is const by default. If you want something to be changed, if you want a variable to be changeable, you have to mark it as mutable, right? Which is a different mindset. And Rust is if you do like an out of bounds error or something, it won't compile. It literally won't compile your code if you have various safety violations. It just won't. It just doesn't compile, which is nice. It's one of the nice things about Rust. So, after C++, every other language is easy by comparison. Yeah, pretty much. C++ is the granddaddy of programming languages. So, but honestly, the way that I learned shell scripting was I took a class in it. So at my university, UC San Diego, we had a 2-unit class called CC80 that was Unix and Shell Scripting. And one day a week, 3 hours, I think, on a Wednesday night. Like, it was like 5:30 to 8:30. And we'd go into this classroom, and there was this old Unix wizard with the Unix beard. And he was up on a raised stage, so he was actually like up above us a little bit. It was an elevated stage. And he would just sit there and do Unix stuff for 3 hours. And he would hand us printouts, like, here's some sample code and stuff like that. He just kind of give each of us a couple of handouts, like, here's how variables work in Unix, the $sign, and there's like some weird, echo path, and there's echo, and there's like setinv, and then there's like printinv, and there's like there's all sorts of like weird idiosyncratic things and stuff like that that we learned. But the basics of it is like learning a new programming language. How do I make a variable? How do I make a loop? How do I do an if statement? And yeah, you can pick those up on your own pretty quickly. How do you copy the results into Excel other than copying and pasting from 120 text files? Put them into a text file and SCP the thing over. So here I am on the server, so I'm going to open up WinSCP. And I'm going to connect. And we're going to go into the hash table. Hash table reference. And I'll just copy these 2 files over here and put them on the desktop. And once they complete, there we go. And now we get to parse these things in Excel. Control L refreshes your screen. Okay, so let's do a little bit of Excel. So for your report, you're going to need to make a 1 to 2 page report that has a graph of the 3 different modes: linear probing, chaining, and either the standard template library implementation of a hash table, or double hashing, or quadratic hashing, whichever you pick for the third. And what I want to see is I want to be able to compare them. I want to be able to look at it, and I want you to tell me which is better, right? And sometimes there's not like one answer. Like sometimes linear probing, a lot of times linear probing is faster in like the low load zone and slower in the high load zone. That's normal. And what I want you to do is to tell me, like, the ultimate question I want you to answer when you write a report to me is, when should I use which version? And sometimes the answer is never. This version sucks, don't ever use it, it's worse at everything. Simple. Goes into your report. This version is better at everything. Okay, simple. Goes into your report. If it's the case where like linear probing is faster at changing but slower at searching, I don't know. You write that down. That's your analysis. Okay, so you're going to get a lot of data points, and you are going to graph them. Okay, and you're going to compare them. Okay, so we're going to browse over to desktop, and we're just going to open the file named A. Yes, I want to open it anyway. And here's all my data, and whatever, it's all good. All right. So there's all my data, and the million version is out of place, but whatever. Okay. So, it'd be nice if this was formatted a little better. And so I'm just going to like kind of move these things. So that's actually the million. I actually named my files, instead of a million, I named it 998 because 1,000 and 1 million are alphabetically next to each other. So the shell script runs 1,000K, 100K, then 1,000K, then 200K. And so the million takes place out of order. So when I actually did mine for realsies, 4, 5, 6, 7, 8, 9, 10, I actually named my million like 999 so that it would appear in the right order. And so I'm just going to kind of move these things around a little bit. It would be better if you didn't have to do this by hand, but whatever. I'm just going to shuffle it around a little bit. I recommend that you have your code print out things in CSV format. I think I forgot. Actually, that one's pretty terrible. Huh? Look at that. And that's an outlier. I'm going to delete you, actually. And there we go. So this is my linear probing mode, and then I can do the same for the chaining mode, which is down here. Okay, so let me show you a couple things. First of all, I did each run 5 times. I deleted this one because it was an outlier. So I cleaned the data a little bit. And what I'm going to do is I'm going to average the data. The reason why I run it 5 times is because if you look at it, you can see you actually get different timings, right? They kind of fluctuate up and down a little bit, right? And so by averaging them, you get to smooth out the data. If you don't do that, you can easily have like 200,000 be faster than 100,000, which looks really weird and non-intuitive. And so in Excel, all of the Excel magical formula type things start with an equal sign. So you just go into a cell, you type equals, and then you type in the name of the magical formula you want to do. In this case, I'm doing average. And so I'm going to average the 5 numbers above me. You can select the range that you wish to average a couple different ways. One way is you can just type in the cell. So A1 is the top left cell, colon A5, and that is the range from A1 to A5. That's the vertical column there. Finish it up with a closed parentheses and call it a day. And then for the next one, we could say equals average. And this time I'm going to just select it with my mouse. That's a different way you can do it. You can see how the range updates automatically. And when you type it by hand, it also shows you the range. I don't want to have to type all these by hand, so what I'm going to do, if you see that little square there, I'm going to click and drag on that little square in the bottom right corner, and that will just fill the same equation in underneath all of them. And you can see this one is C1 to C5, this one is D1 to D5. Nice. You don't have to retype it. It actually updates the formula as you do that. Or you just select all these things here and go to fill right, named after the famous programmer Phil. So you can do a fill right or Control R for short, and it'll fill them all under. I like to bold it just so I can see what's going on here. These are my average numbers. So this is my average running time. Time for linear probing for input Bob, or something like that. Okay. So Bob is like a mix of like inserts and removes and searches and things like that. Now I need to graph it. Dr. Filbert Fillington, that is absolutely correct. So are you supposed to use a mix of insert, search, remove, and change? I've given you mixed answers to that. So what I would recommend you do is you make one set of input files that are a bunch of inserts and a bunch of searches, and a different one that's a bunch of inserts and a bunch of removes. Another one that's a bunch of inserts and a bunch of changes, and then one that's a mix of all. Okay. Or you can read the README file, which says something different, which all of them are mixed, but you run it at different loads. You run it at 30% load, 60% load. Okay. Do it either way. Either way is fine. Okay, so how do we graph something in Excel? We just select the data, and we go over to insert, make a line chart here, and you can set the title. This is going to be Bob linear probing. And then you're going to do one for linear probing, one for chaining, one for quadratic, double, or standard library. You can combine the 3 into on one chart if you want. Cuts down on the number of graphs you have to make. It's fine too. I recommend having a title on the axis. This would be the title on this would be seconds, and this would be size in hundreds of thousands. Right? Add a axis label for these. Different color line if you want, or you just have 12 different graphs. It's all good to me. I don't care. All these are going to get copied and pasted into your Word document. So you're going to copy that, come into Microsoft Word, and oh shoot, yeah, I need to finish that. And then come over here, and then here's my report. Hit paste, and so you just have 12 graphs, or like I said, you can combine the graphs into, you can have 3 lines on the same graph. It's all good. And then just have a couple paragraphs of analysis. Linear probing was faster at this, it's slower at this. Okay. If all else is the same, then personally I would recommend using the standard library because it's less work, right? You don't have to code anything, right? Because like for linear probing and chaining, you had to code them yourself. For the standard library, you just use the standard library one. It's less work on your part. Right. So if I ran everything mixed at different loads, that is correct. If you're doing it the other way, it'll, so it's fine. So 30%, 60%, it's all good. You're fine. Okay. Do we have to make the standard library hash a hash class? Yes. If that's your choice for the third one, you have to use unordered set, basically. Like I said, I gave two different answers on this. One in the readme file, one in the lecture. You do either. It's fine. And what I'm looking for, what I read is the different graphs. And I can usually tell when the code's buggy, right, by actually just looking at the running times. Like, oh, you did an order in insert, right? I've looked at a lot of students' codes recently over the last weekend, and there's a lot of code that's like, I'm going to go through the entire vector from front to back, looking for the thing and deleting it. No, don't do that. You want to hash to the right location, and if you find it, and the spot's filled, and the data matches, then just mark the bucket status as deleted. That's all you have to do for delete. Okay. Don't iterate across the whole thing. If you do an order in when it should be an order one, it will be revealed in the graphs. The graphs will show you did it wrong and you will lose points. Okay. So, what did we learn today? Unix piping, Unix input redirection, Unix shell scripting. All very useful stuff. Incredibly useful stuff. Automation. Very useful. Save your sanity, save your time. Have the computer do the grunt work for you, not you. Once you get your timing data, bring it into Excel however you want. You just copy and paste it if you want, or you can have your code outputted in CSV format, which will make it easier to import into Excel. Average your runs together, graph, copy paste into Word, and write up your analysis, a couple paragraphs. Which one's better? One of the test cases, 9 was inserted twice and removed once when 9 was searched where it said not in table. That is correct. There are no duplicates allowed. So the hash table does not allow duplicates. Never spend 6 minutes doing something by hand when you can spend 6 hours failing to automate it. Yeah, you know, like I said, like, it was a Friday night. My friend was sitting there wanting to run 500 runs by himself in the computer lab. I'm like, come on, let's come with me to rock bottom. We'll drink some beer, play some pool. I will show you how to write a shell script that will run the thing 500 times and write the results to a file. He's like, nah, it seems too much work. I'm just going to do it by hand. Like, you see how little work, you know, it is, right? Like, you just, I don't know. Like, I just made this in the previous class, right? Like, that's it. For each size from 100,000 to a million, pass it to the generator, write the results into a file called input bob 100,000, input bob 200,000. Don't know. Yandere dev, yeah. The code is famous for not being well optimized. Is even so memeish. It's so hot right now. Okay. Duplicates shouldn't be inserted. It will not feel good afterwards. It's going to get that Unix book. Yeah, you should be able to find it for like a couple bucks. It's drastically outdated. You know, I got it for a couple bucks. It was outdated when I bought it, and that was 25 years ago. You know, but all the Unix utilities are still the same. And like I said, it's very well written, very clear. Just open it to a different thing, learn something. That's how I learned Vim too. I had a Vim cheat sheet. I had it printed up on the wall, and I would close my eyes, be like, I'm going to learn today this one. Oh, the S command. What does that do? Okay, let me try S. S. So it deletes a letter and then puts me into insert mode. Right, and I never understood it. Right, like it just seems like I could just type X and I and do the same thing. But then I saw Santanu, who's now teaching at Fresno State. I saw him. Let's see. I saw him do something like this. 3S long. I was like, 3S. Oh, it deletes 3 letters and puts me into insert mode. Okay, that's interesting, I guess. Dot. I'm like, oh. All right. Dot repeats your last command. Because when you do an X and an I, those are two different commands, and dot will not repeat it. /int dot n dot n dot n dot n dot. And you can, it's like a manually controllable search and replace without having to Google the stupid Vim search and replace every time, which I don't like anyway. I never like doing a global search and replace in my code because there's always a case where like there's something that will change that shouldn't have changed. And you know, your dialog box says, "Hi, welcome to the ent day." And you're like, wait, that dialog used to say welcome to the long day, and now it says welcome to the ent day. What happened? I'm like, oh, I did a search and replace changing long to ent. You know, I never trust the global search and replace. I like doing everyone by hand for that reason. And you can make it very fast. Just n to go to the next search, dot to repeat the last substitute, and you just go through the file that way. Just look at everything, double check it. Okay. And so with Vim, yeah, like I said, I just look at this. I just close my eyes, pick a random command, learn it. And that's how I, you know, don't try to stress yourself. Don't try to, you know, learn everything at once. Just one Unix utility a day, one Vim command a day. And over the span of a year, you know, you're good. Just constant ongoing growth, just a little bit at a time, makes all the difference in the world. Okay, so any point in time when we don't want to use an I++ in a for loop, can use sequence to skip over numbers in that way. Yeah, I guess. I mean, you probably use sequence. It's basically the part of the for loop that generates the numbers, right? Do you need to use std hash for the STL hash class? I probably would. Yeah. Do hashing. Yeah, I wouldn't do that. It's terrible. I remember seeing a graph that tells you when you should automate versus doing it by hand. Let's see. Shoot off an hour a day. Yeah. Okay. I don't know. Basically, my criteria isn't mathematical. My criteria for automation is, does it annoy me? Right? So it didn't annoy me to copy and paste those numbers 10 times. So I just did. Does it annoy me to run something 120 times? Yes, it does. I write a shell script at that point. And the thing is, it's not really like, see, it's like you're spending more time than you save. The time that you spend learning how to automate things applies to all future times you automate things, right? So learning Unix shell scripting doesn't just apply to like the one task. If you learn how to automate something using Unix shell scripting, it applies to every repetitive task you do in computer science ever. Not on Windows, but who cares? All right, for that there's AutoHotkey and stuff like that. But like, you know, learning Unix shell script is something that every Unix nerd should learn. It's really nice. And then to automate something, like to write that generate script took me like, I don't know, a couple seconds. Like it's, you know, rather than me running generator 120 times, I just run the shell script, you know. It makes it 10. Right? So, you know, do I get annoyed at a task? If I do, I automate it. If I don't, I just do it by hand. And there are things that like I'll sometimes just do by hand, like copying, pasting 5 numbers. Okay, sure, whatever. You know. When I do grading, I have an auto grader that generates a list of everyone's usernames and all their grades, and I could figure out a way of exporting those into a format that Canvas liked and then uploading it into Canvas. And I could do that, but I don't. I actually look at your grade and type it in manually. And sometimes I make mistakes. But the reason why I do that is because, one, it gives me an idea of what students are up to and which students are doing well and which students are not doing well. So I actually like having my eye on everyone's scores for that reason. 2, I don't trust that it'll import properly, and students might end up with a grade of like 1,000 when it should be out of 10, you know? And so I'd have to review the grades all manually anyway. And it also just doesn't take me very long. Like I can just sit there and go and bring all the numbers over very quickly. It's not annoying to me. And even when some things should annoy me, like something taking 15 minutes that I could feasibly shave down to like 30 seconds, if I run it once a year, then it just doesn't bug me. You know, in my professional career, I have a report. I think I've told you this before. The annual report at the end of the year runs hundreds of thousands of statistical tests. It does all this work, and it repeats a lot of the work. I could make it much faster by just writing down the things and loading the cached values, and I could rewrite it in a day. And I don't, because once a year I hit a button and it just runs for 15 minutes, and I can play a video game, or I can go to Starbucks, get a coffee, come back, it's done. Like, it just doesn't bother me because I run it once a year. And sure, I can make it run in a minute instead of 15 minutes once a year, but you know, it just isn't a big enough issue for me that I care about it. So, you know, if I had to run it every day, I would be on top of that in a second and be like optimizing my thing out of it, you know. But once a year, it's like, okay, you know. The actual typing of the report, because I have to put it into English and stuff, that takes hours, right? The data and the analysis, 1 minute, 15 minutes. I don't care. How do you run the generator with the timing script? The generator and the timing script are two different things. Okay, so the generator makes the input files. Okay, so generator makes the input files. You run generator and you pass in a number 100. It makes 100 inserts, 50 removes, and 100 searches. You can edit this file, and you should edit this file to do different things. So the generator right now is kind of a mix, but you should change it to have a version that does insert and remove, insert and search, insert and change. And then I wrote this generator script here that I posted into chat, and this automates the generation of the input files. And then the timing script here, it's going to search for every file that starts with insert Bob, or I think there's an insert. Okay. And then this will run your program, your actual hash table program, using the input files made by the generator. Every file in the current directory that starts with insert _ Bob, it'll run. And so what it's doing, it's going to run your program in mode 0, mode 1, mode 2, linear, chaining, double, or linear chaining, STL, whatever. It runs it in each mode for each of the input files that you make. You have to make these files. And then it runs them 5 times. And then the timing results get written down. So, do most professional programmers use Unix? I am highly biased on that point, and I don't think you're a professional. No, I'm kidding. No, there's two different worlds. You know, there's the Linux world and there's the Windows world, and then Mac, but who cares, right? Which is it's Unix also, right? So, you know, the entire Windows Visual Studio, the entire ecosystem is all different, right? You know, they don't have but Windows has been adopting Linux, and because it's better, you know. So you can do shell scripting on Windows now because they've got WSL and Bash for Windows. So you can do Bash scripting on Windows now because it's just better, because the DOS command line is terrible, right? So I wouldn't say all professional programmers use Unix. There's a lot of people that have just never learned Unix and are too afraid to learn, and they know PowerShell, and they know Visual Studio, and they've got all their things, like they have their whole thing set up, you know, and they got their whole thing going on, and that's fine. More power to it. You know, I'm a Unix nerd, and I will not apologize for that. So, I will never return to Windows. Though you do miss playing video games. Well, that's why you have your game machine, and then you have your development machine. The game machine is Windows, and it has Steam and Epic Game Store, and then you have your development machine that is actually Unix. You know, so. For all your serious stuff, you use Unix, and then for, you know, it's like a game console, right? It's Windows. It's like Xbox. Okay, so, yeah. So that's your assignment. Have fun. You can do it. You can do it all by hand if you have to, but like I said, this assignment's designed just to be painful enough that if you needed to do it by hand, you could do it, get it done, 20 out of 20. but it's designed to be irritating. That if you had to do it by hand, you'd be like, I don't like this. You know, it's designed to kind of provoke you into learning shell scripting. Because if you actually learn shell scripting, it will make the rest of your life better. Okay? Doing it by hand builds character. What do you download to do this on your own machine? Look at Mincarelli's talk on Friday. He did a whole thing on setting up WSL on your Windows machine. If you have a Mac, it already has Unix. It is Unix. Mac OS is a Unix system. Do you use the server for professional jobs or your own machine? Yes. Yes, I use both. You know, I use both Linux and Windows. You can have the same OS and the same PC. You can. I used to dual boot and things like that. Dual booting's annoying. You could run a VirtualBox. That's also kind of annoying. More power to you if you like that. But for me, it's just easier to have two different machines. I have my Ubuntu server, and I got my PC. I just use both. It just seems easier to me. How many hours did it take my run to finish? Yeah, it'll probably take you a couple hours. Don't wait till Tuesday night. Tuesday night's going to be... If you don't get it done on time, ain't nobody's fault but your own. You've been properly warned. There's memes from previous years on this topic. There are memes. So one of the students screenshotted it. Although this is actually HTOP with a low load, so it's not perfect. But the server is screaming for CPU, Kearney, people with their own server. Yeah. So this was made after this assignment, actually. The only downside is HTOP is actually not showing a 100% load. If you want to know what the load averages here mean, let's see, because this is going to come up tomorrow night. If you want to know how the load is on the server, if you type uptime, this will tell you the current load. Anything below 1 is fine. It means it's not loaded. If you type top or htop, which I think have aliased together, it also shows you the load averages. Short-term, medium-term, long-term load. What the numbers mean is how many processes need CPU time or waiting for CPU time and can't get it. So if the number is below 1, you're fine. That means the server has enough capacity to handle everybody. If it hits 1, that means on average there is one process that is trying to do computations that is waiting in the line. And then it swaps a person out, they come in, they run for a while, then it swaps the other person back in, stuff like that. If the number is 2, it means on average there's 2 processes that are trying to use CPU and can't get it. And if it's 15, that's really bad. And the server is going to be, you're going to be typing things and it's going to be like, molasses. You're trying to use Vim and Vim is going, no. This is what it's going to be like tomorrow night. It's going to be hard even to develop. It's a life lesson. Okay? You got 20 people all running their timing script. Even doing Vim is going to be painful. And it does prioritize Vim. It does give you a better priority for Vim, and the timing script by default runs at a low priority. If you look at the timing script, it runs your code with a niceness of 19, which is maximum niceness, which means that it will allow interactive processes to take priority. Okay? If you want your input thing to run faster, take that out and hose other people. It's up to you. I can run at negative niceness, by the way. I can run my stuff at negative niceness. You can't. So by default, the timing script runs at a very nice level. It tries not to hose other people. Vim by default gets up prioritized. But even still, when you've got a bunch of people all hitting the server, which is not powerful, it's a $20 a month server. It's not a powerful server. I pay for it myself. The school doesn't pay for it. It's a 2-core system. And I think it might even be a 1-core system pretending to be a 2-core system. So, run it on your own machine is my advice. Or get it all done tonight. All right? So, yeah. don't get it done by Wednesday, yep, life lesson learned. 20 points. Get it done soon. All right, that's it for today, guys. Thanks a lot for coming out. Hope you all learned a lot. Wasn't C++ today, it was Unix, but all that stuff's really important. All right, peace out.